Basically given a list of days that you will travel, and then you're given a cost, and your job is to optimize like the combination in which if I travel 1 day, 7 day, or 30 day for those particularly, what is the most optimal one. So for example, you're given these days 1, 4, 6, 7, 8, 20 is your travel date, and you're given a cost which is on day 1 you can travel for $2, on 7-day pass is $7, 30-day pass is $15. So the answer is 11. The reason for that is because on day 1 you travel at 1-day pass which costs you 2, and then you travel a 7-day pass until day 8, and then you travel another 1 day on day 20. So that will give you a total of 11. So let's see for another example. Example 2. So you're given a 1, 2, 3 until 10, and then suddenly it becomes 30, and then the next day is 31. So the same amount of cost, so the output is 17. The reason for that is you can just use a 30-day pass until the 30th, because the 30-day pass will cover 30 days until the 30th, and then you do for a 1-day pass which costs you 2. So 15 plus 2 is equal to 17. Yep. The constraint is the number of days that land is less than 365. Yeah. So maybe what we could do is to further understand this, you go to some example. So for example, you're given an array 1, 4, 6, 7, 8, 20, and your cost is 2, 7, 15, right? Notice that in order for you to find the minimum cost that you need to travel, you need to basically find all the combination on every day that you're traveling. So for example, these are your planned dates, and on day 1 you need to compute for 2 days, for the 1-day pass, for 7-day pass, and a 30-day pass every time you move to the next day. So this is more like a recurring sub problem, wherein on the first day I will calculate 1-day pass, 7-day pass, 30 pass. Then after I calculate the 1-day pass, I will recalculate again the 1-day pass, 7-day pass, 30-day pass after the 1-day pass after you've done the 1-day pass. Same case for the 7-day. Let's say you did the 7 days initially, you still have to recompute again all of these 3 possible day pass on the remaining days, which is 8 and 20. So yeah, this problem needs to be solved using recursion, and it needs to be like a dynamic programming type of problem. So for example, you're given us 1, 4, 6, 7, 8. Let's dig in deeper. Notice on your initially 1 day, right? Notice that you can use just a single ticket, a 30-day pass. 30-day pass would cover all the 20 days you need to travel. But that doesn't mean this is the answer, because you need to find the minimum for each of this iteration. So you basically just store 15 there. And then let's try to do using a 1-day pass instead of immediately using a 30-day pass. So let's in this iteration I use a 1-day pass, which just give me a cost of 2. And then on the next iteration, what I do is I immediately use a 7-day pass until day 8, which gives me a total cost of 9. And then on day 20, because there's a skipping days here, use a 1-day pass again, and this will give you like 7 plus 2 plus 2. This will give you 11. This is the minimum cost of traveling for this itinerary. But that doesn't mean we can immediately return the result, right? Because we still have to do the combination for all the possible one. So in this case, let's go and continue ahead and finish this. So in this case, like, okay, I did a 2 days in the first, 1-day pass on the first day. So 1-day pass on the first day. On day 4, I did another 1-day pass. Instead of using a 7-day pass, I did a 1-day pass, which give me 2. So 2 plus 2 is 4. And on the day 6, what I did was I used a 7-day pass, which will cover 6, 7, 8, right? And then the day 20, I use another 1-day pass, and this will give you a total score of 13. But this is not the minimum, because the minimum is basically this. Same case here, 2, 2, 2, and then on day 7, you use a 1-day pass. But if you use a 1-day pass on day 7, definitely you already know that this is not the optimal solution, because use a 1-day pass here. It's possible to use another 1-day pass on day 8. Use 1-day pass on day 8 and another 1-day pass on day 20. This will give you 6, 8, 10, 12, which is not the minimum. The minimum is actually 11, right? So this is using a 1-day pass on the first day. What if I use a 7-day pass on the first day? Use 7-day pass on the first day will cover 1, 4, 6, 7 until here. And then on day 8, use a 1-day pass, which gives you 2. And then day 20, use a 1-day pass, which gives you 2, which will give you a result of 11. Basically, it's the same case as this one, using this combination here. So your job is basically to try all the possible recursion, iteration for all of the costs for each of the day, and then the remaining days afterwards. So when you use remaining days, and you compute again these 3 possible day pass on the remaining days. So maybe we can go again in the coding section so you can further understand how to do this. So we mentioned a while ago that you need to compute for each of the possible cost combination, right? So you need to this will be our days. Recursive function where for you compute the number of days, right? K is less than 3, K plus plus. At the same time, we need to compute the number of, we have to iterate through all of the days. So basically J is starting with I, and then J is less than, okay, you don't have to start from here. You can do it, just move it here. Well, J is less than the length of days. Okay, I'll create a variable here, so assign it there later. So then I don't have to pass it in the argument, cost1. It's like basically a copy. K plus plus. Okay, so this is you're trying to skip the number of days, but you need to make sure that it's always less than the value of your of the jth day, right? So this should be day j should always be less than the days of this current iteration, which is the I, plus the duration of k. So what is the duration? The duration is the number of days. So what are the number of days that we have? So we have 1, 7, and the idea here is you don't exceed for 7 days. You don't overlap on the number of days in the array. For example, I'm currently at day 7. You want to make sure that you're less than 20, right? Because 20 is the next day. So if you 7 plus 7, that's 14. You're still within the 20. Then it's fine. You can still compute for 7 as the next day, right? Because you're still less than 20. Basically, it's more like capping the number of days based on the number of days that you have on the next day, on the next array. So for this case, what you can do is basically answer, and you need to have a minimum between the costs, right? So basically you're calculating the cost of k, and then you need to add that with the remaining days. The remaining days now, because these are the days you just keep, add the remaining days here, so recompute this dp function again. So you need to put the variable ans, which is int, and then just return ans here. Okay, so minimum cost is days. You just assign it days here. Cost, just assign it to cost cost 1, and then return dp day 0. See if it's gonna work. This one here, and then we're missing a function called minimum. It's a very simple function. It does is just check if a is less than b. Return b. cost, this cost one. Okay, out of memory, can't allocate this block. Okay, we basically have to check if I is greater than equal to the length of days. Is your overflow. You're already at the end of your number of this check. We basically return 0 here. Okay, so the output is 0. Okay, so basically you need to set this as mat, because we're using a minimum, right? Mat max int 32. Okay, I'll pass. It's not yet optimized. Yeah, it's time limit exit. So basically this is like an exponential, right? The length of array raised to 3 raised to the length of array. But so how do we optimize this? Well, you notice there's a lot of duplicate computation for answer. What we can do here is store in an array the result of answer, so we don't have to recompute it again. So in this case, we'll probably do something like this, or it's 366. We'll store all the days. It's possible that it's like 1, 2, 3, 4, 5. The length of I is like 1, 2, 3 until 365. What you can do here is just assign. Okay, now what we can do here is check if memo I is not equal to nil, and then basically return memo I here. And what we need to do here is basically store the result. Memo I equals to pointer to ends. This is a pointer array of days. Let's see if it's gonna finish. Type in, okay, use a pointer here. Okay, there you go. 0ms, submit it. Okay, there you go. So it's accepted. So this is actually how you solve this problem using dynamic programming. If you like this video, please hit like and subscribe. Feel free to drop down your comments below in the comment section, and we'll see you again in the next episode of this LeetCoding. Thank you for watching.